All right, so in this video, we're going to look at finding the inverse of equations. So an inverse relation, basically all you're going to do is you're going to swap out the x's and y's, and then if possible, try to rewrite it as y equals. So basically here in this first function, what I'm going to do is I'm going to set it equal to y, and then I'm going to take and I'm going to swap my variables. So let's say x equals square root of y minus 1, and then go to rewrite it as y equals. So I'd add the 1 to the right hand side, and then I would square both sides, and so my inverse function, which would be f negative 1 of x, is going to be x plus 1 to the second power. Now for part 2 of this problem, what we want to do is we want to compose the two equations that we have with one another. I want to put the inverse function of x back inside of the square root of x minus 1 to see what happens. So I'm going to write x plus 1 to the second power, and I'm going to put it inside of f. So let me change colors. So that's going to be inside of the square root and then minus 1 on the end. And then we want to simplify that and see what happens. Well, I take the square root of x plus 1 to the second power. That is going to make the absolute value of x minus, or excuse me, that's going to make the absolute value of x plus 1 minus 1. Now, in context of this particular problem, we're trying to see what happens when we totally simplify this thing down. I'm going to take out the absolute value of x because we're not specifying a domain, and this problem would reduce all the way down to just x. Now let's go to the second problem here. So I want to find the inverse again. So I'm going to set it equal to y and start trying to rewrite this, do my variable swap. So x equals y squared minus 4y plus 4. And trying to get it to be y equals from this point is going to be rather difficult because I have a quadratic expression in terms of y. So I have to think a little bit outside of the box about how to proceed here. What I can do is notice that right hand side looks like a perfect square. I can factor that and rewrite that as y minus 2 to the second power. Now this becomes much easier to rewrite as y equals. All I would have to do is take the square root of both sides from here and give me the square root of x equals. Remember that the square root of something squared creates the absolute value. So the absolute value of y minus 2 here. And then to take off the absolute value, we would have to account for y minus 2 creating the square root of x, and y minus 2 creating a value equivalent to the negative 1 times the square root of x. And so what we have really is we have two separate functions to account for. If I write those as y equals, now I'm going to go ahead and use function notation. That'd be, all I would need to do is move the 2 to the other side. So it'd be 2 plus or minus the square root of x. So we'd have to pick which inverse function we were going to use based on, remember that I could rewrite f of x to make it a lot easier because f of x was a perfect square. I could rewrite that as x minus 2 being raised to the second power. Now, I go in, I try to perform the composition of functions at this point. So what I would do is I would start writing my f function, but I would not write the x part because we're getting ready to substitute in there. And I'm going to put the inverse function where x was, so 2 plus or minus the square root of x. And we start working our way through the simplification process. Well, the 2's are going to cancel, so I have positive or negative square root of x being squared. Well, regardless if the square root of x is positive or negative, when I square that, that is going to make just x. All right, now let's look at a rational function. Let's try to find its inverse. So I'm going to set it equal to y. Go through the first step of making my y's x's and my x's y's and rewriting. So we'd have x is equal to 3 over 2 minus y. And then I want to try to get this thing to be y equals. Well, in order to do that, I'm going to have to get y out of the denominator. So I'm going to multiply by the denominator 2 minus y to both sides. That's going to take it out here. And we'd have x times 2 minus y is equal to 3. Now, to get it to be y equals, I wouldn't necessarily want to distribute that x here. What I would want to do is get the x to the other side away from the y. So I'm going to divide both sides by x. That gives me 2 minus y is equal to 3 over x. And then I could just rearrange this and I have my inverse function, y equals 2 minus 3 over x. So I'm going to go ahead and write f as 3 divided by 2 minus, now I'm not going to write the x because where the x was is where the inverse is going. So I'm going to put the inverse function into x where x was into f. So instead of x, I'm going to write 2 minus 3 over x. And I'm going to put it in parentheses. 2 minus 3 over x goes inside of parentheses. And then from here, I'm going to look to try to simplify the problem as far as I can. So we'd have 3 divided by, the 2's are going to cancel out, and it's going to leave me with 3 divided by 3 over x. And we could rewrite that, do skip, change, flip. That'd be 3 times x over 3, which leaves me with just x. Now let's find the inverse of a rational function that has a variable x in both the numerator and the denominator. So I go ahead and complete my first step, which is going to be to swap my x's and my y's and rewrite the problem. So x equals 5 plus y over y minus 4. Now here I need to try to get this to be y equals, and I cannot do that when I have y in the denominator. So I'm going to go ahead, I'm going to multiply by the expression the denominator has y in it to both sides. So that's going to give me x times y minus 4 is equal to 5 plus y. Now here, unlike the other problem where we just turned around and we divided by x, that's not going to help me out because I have y's on both sides. So in this case, I'm going to need to distribute that x, and that's going to give me x times y minus 4x is equal to 5 plus y. And I want to get my x's, I want to get my y's on the same side and everything else on the other side of the equal sign. So if I move that y to the left, it gives me xy minus y is equal to, move that 4x to the right, 5 plus 4 times x. And then I want to go from here. Well, in the left side, both terms have a y. So I'm going to factor out a y, and that's going to leave me with x minus 1. So y times x minus 1 on the left is equal to 5 plus 4 times x on the right-hand side. And we're almost there. All we have left to do to get this to be y equals is to divide by x minus 1. And so our inverse function, which is what y is representing, is equal to, fix that equal sign, is equal to 5 plus 4x over x minus 1. Okay, so now here we're going to look at doing the composition of f with its inverse function. And so what I've already done is I've already written f, but just haven't written the x parts because f was 5 plus x divided by x minus 4. Now, what I'm going to do is I'm going to write everywhere the x was for f. So everywhere that f had x is where my inverse function is going to go. So I'm going to put 5 plus 4x divided by x minus 1, and both the places where the x was. And then I'm going to look here, from here to try to simplify. Well, this problem, we have fractions within fractions, so I'm going to start simplifying by multiplying by the denominator of the two fractions. I'm going to multiply by x minus 1 over x minus 1 and look to rewrite. So when I do that, I start folding that to both parts. I'd have 5 times x minus 1. And then when I multiply the x minus 1 to the second fraction, it's just going to leave me plus 5 plus 4x. Divided by, do the same thing in the denominator, distribute the x minus 1. It's going to give me 5 plus 4x. And then multiply it to the minus 4. So minus 4 times x minus 1. And now we're looking to clean up that expression. So we'd have 5x minus 5 plus 5 plus 4x. That's my numerator. Divided by 5 plus 4x minus 4x plus 4 in my denominator. And we look to see if some things will start to cancel. In the numerator, the 5's will cancel, and the denominator, the 4x's will cancel, and we're left with 9x divided by 9, which simplifies down to just x. So in all four of these examples, when we composed a inverse with its original function, everything went away except for just x. That brings us to the function, or the inverse function composition rule. So if I have two functions, f and g of x, and they're considered inverses, what that means is if I compose those two functions, if I put g inside of f or f inside of g, everything's going to cancel out. It's going to leave me with just x by itself. And so let's apply that composition rule here 3 times and confirm that we have inverses without actually finding the inverse itself. So we're right here in this first problem, and I want to perform the composition. So f of g of x, and see what happens here. So I'm going to take g, I'm going to put it inside of f. Now this looks like it's going to get a little ugly because f, I got to square that x, I got to multiply x by 2, and I got a radical in g. So I'm going to look to see if I can't rewrite f to make life a little easier. So f here, because by looking at it, I see it's a perfect square. So I can write it as x plus 1 to the second power. And so f is in purple, and I'm going to rewrite that. So x plus 1 to the second power, and where the x is, I write g, because I'm putting g inside of f. So I'd have negative square root of x minus 1. And now I'm looking to simplify this. Well, the 1's will cancel out. I have the negative square root of x being squared. And if I square the negative x, I'm left with just x by itself, which means that f of g of x yielded just x, which means that f and g are inverse functions. Now let's look here at another example. So I want to perform the composition of functions and see if everything cancels out except for just an x. So f of g of x. So I'm going to take g, put g inside of f where the x is, and see what I get. So let me start. I'm going to write g. So x plus 4 to the third power minus 3. That's going inside of f. So let me change colors. So let's let f be here in purple. So that was where x is. So I got to have minus a 3 here. All of that being raised to the 1/3 power minus 4. So all of this is the f function. And now I'm working to simplify this as much as I can. And so in the very inside, I have x minus 4 cubed minus 6 to the 1/3 power minus 4. Now, I'm looking at this, and the issue that I have from really being able to proceed to see if things would cancel out is this minus 6. If there was no minus 6 here, I could take the cubed root of x plus 4 to the third, that would undo one another, and then I could go proceed. This is not going to simplify down to make f of g of x equal x. So f of g of x, I know, is not going to simplify down to x. And so I'm just going to say they're not inverses. And let's look lastly at one more here. So I want to perform the composition and see if f and g are inverses of one another. So I'm going to let g be here in purple, and let me go ahead and pre-write f. So f, I'm going to keep that one in black, and we'll try to simplify from here. So f is 2 plus x over x minus 5. And so in purple, it's going to be g. So g's going everywhere there was an x inside of f. So 2 plus 5x over x minus 1, and 2 plus 5x over x minus 1. And then we'll go from there. So what I'm going to do from here is I'm going to work, and I'm going to multiply this problem by the denominator of that fraction to try to get it to simplify. So I'm going to multiply both the numerator and the denominator by x minus 1. So I'm going to FOIL that in to both terms, or distribute that in to both terms. So we have 2 times x minus 1. And then when I multiply it to the second term, that fraction, all that's going to be left is that numerator, so plus 2 plus 5x. So that's my new numerator. My denominator, multiply the x minus 1 to the first term, leaves me with just 2 plus 5x. Multiply it to the second term, I have minus 5 times x minus 1. So from here, we're going to distribute in that numerator and look to see if we can combine like terms and things and start canceling. So I have 2x minus 2 plus 2 plus 5x divided by 2 plus 5x minus 5x plus 5. And some things will cancel out. In the numerator, I got the 2's are going to cancel. The denominator, I have the 5x's are going to cancel. And my problem becomes 7x divided by 7. And everything cancels out and leaves me with just an x. So F and G are inverses.